Hello, everybody. Today we will be discussing the final topic of our DNA unit, which is on mutations. And in general, a mutation is any heritable change in the genetic information. Usually involves a change in the DNA. Now, a mutation is neither good nor bad, it's just a change. Sometimes it can have a beneficial effect, and sometimes it can have a negative effect, but the mutation itself is just the change, and the change is never good or bad. Okay, so our mutations will fall into one of two categories: a gene mutation or a chromosomal mutation. Gene mutations generally affect one single gene, and a chromosomal mutation can affect multiple genes within a chromosome. Um, so, one example of a gene mutation is called a point mutation. And a point mutation involves just a change to a single nucleotide. And that can take three different forms. We can see the three different forms here. A substitution mutation is a type of point mutation that just substitutes one amino acid, or sorry, one nucleotide for a different one here. So it's exchanging one base. There's supposed to be a C here, and it changed to a T. An insertion mutation inserts an extra nucleotide or extra nitrogen base right here, and it changes all of the amino acids afterwards because it's changing the three-letter codes that have been reading after that. And deletion works similar, right? You delete a nucleotide, and again, it messes up all the next ones after that. And so if we're looking at this, the least likely to be harmful out of all of these types of point mutations are called the substitution mutations. Because if we look at it, sometimes a substitution mutation will have no effect at all. Sometimes it does have an effect, right? So let's just look at here, right? So before the mutation, the mRNA sequence read CGU. And so we look, CGU codes for the amino acid arginine. Afterwards, it reads CAU. CAU is histidine. That's a different amino acid base, right? But we can have situations where it might not change a single one. All right, so let me show you a second example that might not have as big of an effect. Let's say that instead of the second letter changing and it going from a C to a T, let's say this last letter changed and it went C or GCT, right? Changing the amino acid sequence here to CGA instead of CGU, right? And so CGA still codes for the same amino acid actually. So that wouldn't change the amino acid that's made. And that's why point mutations generally are less, or substitution point mutations are generally less harmful than other types of mutations because there's a chance that it has no effect. Right? We could look around this codon table and see that multiple codons can code for single amino acids, right? If you look here, serine can be coded for by UCU, UCC, UCA, UCG, right? If there's a mutation, it can kind of be overcome because multiple codons code for the same amino acids. That's different than if we're looking at an insertion or deletion mutation, which end up either inserting or removing a single nucleotide, and that single base from the code, and that changes all of the amino acids after that, generally messing up the gene completely. So those are examples of gene mutations, and those are point mutations of gene mutations. Next, we're going to talk about chromosomal mutations. Chromosomal mutations can mess up large chunks of chromosomes. And on each chromosome, there can be hundreds of different genes. And so if you're messing up a large chunk of a chromosome, you could be messing up many, 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 many different genes. And so here's just some examples, right? So for each one of these, the top chromosome is the original one, and then the bottom is what happens, right? So a deletion is when a big chunk of the chromosome just gets deleted for whatever reason. A duplication mutation is when a chunk of it becomes duplicated. Inversion is when a piece of it switches around. And a translocation would happen if a piece from a different chromosome, let's just say this was chromosome 1, right? And a piece from chromosome 5 came and switched places and inserted in here. That would be a translocation mutation. All of these have far-reaching effects, and generally the chromosomal mutations are more dangerous than a point mutation. Mutations are generally random, but sometimes there are chemicals or physical agents in an environment that can cause mutations to happen at a higher rate. Those are called mutagens, chemicals that are known to cause mutations in the DNA. Couple examples: tobacco, or nicotine, alcohol, radiation. Those are generally some common ones that cause mutations. And then let's just look at an effect, right? So here's an example of a mutation that dramatically changes the structure of a protein. And so this is sickle cell disease. Sickle cell disease affects the shape of blood cells. Here's a normal blood cell, and here's a blood cell that has sickle cell disease. In this case, what happens is the protein that gives a normal blood cell its shape is missing or damaged. And so what happens is a good chunk of the blood cells instead look like this. It can still carry oxygen, but at a significantly lower rate. So people who have sickle cell disease are at higher risk for heart failure and respiratory failure. And they also have more issues with like blood clotting. So if they get a cut, it's more dangerous to somebody who has sickle cell disease. Sometimes mutations can be beneficial as well, right? A lot of useful mutations show up in nature that just slightly alter or change an organism and allow it to function better in an ecosystem or an environment. That would be an example of a beneficial mutation, something that wasn't there before. Protein gets slightly altered and somehow it becomes useful in that organism's environment. That would be a beneficial mutation. So that's the basic introduction for mutations. Thank you all for watching.